Alright guys, welcome to our Unit 9 Quiz 2 study guide. Let's go ahead and get started. I'm going to do the even problems. Odds, once again, are included as always, just as extra practice in case you want to get a little extra practice of each type in there. So, let's begin. Just got a variety of problems. Most of it's just solving equations of logs and exponential functions. So, here we go. So how do we solve log equations? Pretty much a three-step process. We want to get the log by itself, then we want to exponentiate, and then we're going to solve for x. And I guess I shouldn't say x because it's not always x, like on this one it's r. But anyway, this part here is the log, so I want to get this by itself, which means I need to get rid of this 6 and the 5. The 6 I'm going to get rid of by subtraction. And the 5 I'm going to get rid of by division. Then we're going to exponentiate both sides. It means I'm going to make each one of these sides a power of some number. And the goal is to know what the number is. Well, if it's ln, that would mean the base is e, and that's the number we'll be using. And then the e and the ln cancel each other out, so I'm left with r equals 2. Okay, so there's that one. Let's go ahead and take a look at another example. Number 4. So, step 1, get the log by itself. This is my log. Notice that whenever they have parentheses around this stuff and next to the log, that means all of that is part of the log. It's part of the argument, is what it's called, of the log. So I only need to get rid of the 3 at first, so I'm going to begin by subtracting the 3. Oops, well, I left quite a bit off there, didn't I? Let me back up. There we go. All right, so there's that. So after you get the log by itself, you exponentiate. Now you don't have to draw these squares. I just do that because I think it's a nice visual aid for teaching, but we're going to make each one of these sides, this one and this one, a power of some number, and that number is whatever the base of your log is, which is 5 in this case. And so this 5 cancels out that log, and I'm left with 5m minus 1 is equal to 5 to the 4th, and that is 625. And then from there, we'll just solve it. So we'll add 1. And divide by 5. So 626 over 5 would be our final answer there. All right. Something that I've been skipping, and I probably should have done that, so let me add that here as step 0, I guess, is to find the domain. Now, the reason I forget about this step is because it's kind of like it's extra work, and a lot of times it just doesn't even really matter, but it can matter on a few problems. So to find your domain, you're supposed to take your part that's in parentheses there, make it greater than 0, and solve. And the reason we do that is because it tells us what m is allowed to be. We just got m equals 626 over 5. And our answer is okay so long as it's greater than 1/5. Now, a lot of times fractions are not obvious to know, like, well, what are they actually equal to? So decimals are a little bit easier, though. 1/5 is 0.2. You can change a fraction into a decimal by dividing the top number by the bottom number. So long as my number is bigger than 0.2, we're good. And I know that 5 goes into 626 way more than 0.2 times. So this is definitely bigger than 0.2, so it satisfies the domain, so it's good. So you'll find that I forget about doing the domain step every once in a while, but there'll be that one rare occasion where you get an answer and you think, oh boy, I got it, and it turns out, oh, that answer is actually not allowed because it's not in the domain. So technically you should be checking the domain every time. Let's go ahead and take a look at number 6 here. And in fact, checking the domain is really important on these types of problems where you have a log on both sides. Those are ones where they very often come out with, well, not very often, but these are the ones where it's most likely you're going to end up with some kind of a false solution called an extraneous solution. So let's go ahead and find our domain first this time like we're supposed to. So I'm going to take each argument and set them both greater than 0 and solve both. So for this one, x needs to be greater than -2. And I'm going to go ahead and just use decimals because I don't want, fractions are not very helpful here. So 4 goes into 6 once with 2 left over, so 2/4, which is 1.5. So there's that. So x needs to be greater than -2, and it also needs to be greater than 1.5. Now, if you think of a number line, -2 is over here. 1.5 would be somewhere to the right of that, right? So we need to pick numbers that are bigger than both of those. So long as it's bigger than 1.5, we're in good shape. So long as my answer is bigger than 1.5, that's an answer I will keep. But if I get an answer that's less than 1.5, then we're going to have to throw it out and call it an extraneous solution. So I'm just going to put that up here. All right. So now that we've got step 1 out of the way, let's do our solution process. So step 1 says get the log by itself. Well, on each side, and that's how these types of problems usually are, the logs they're already by themselves, right? There's only one log on each side, so we're good there. So we could skip step 1 here. But let's go ahead and do step 2. Step 2 is to exponentiate both sides. Now you could exponentiate both sides. You don't have to. You could actually just cross the log off both sides and solve. Now, if you want to exponentiate, though, it still works. It's just that it's more work. So you don't have to do this step if you just notice, oh, I could just cross the logs off. That's fine. But there's that. And either way you want to go about it, we end up with 2x plus 4 equals 4x minus 6, and we just solve what's left. If I divide both sides by 2, I end up with x equals 5. And that is bigger than 1.5, so it's a good answer to keep. Right. So check your domains. And when it comes to having a log on both sides, the easiest way is just to drop these off and solve from there. But I was showing you that if you want to just follow the steps I give, exponentiation works also. So not a big deal how you want to pursue it. Let's go ahead and take a look at number 8. Now, on these types of problems where you have a log on both sides, we want to get the log by itself, but the problem is that there's 2 logs. So actually what we want to do is put them together as 1. And when you have 2 logarithms that are joined by a plus, the way you can put those together as 1 log is by taking the argument from each log and multiplying them together. Put brackets around that. So we need to distribute that 8 in there, which gives me 16x plus 72. So anytime you've got 2 logs that are being added or subtracted, you're going to have to put them together using one of our properties. And for this property, if it's plus, you multiply the arguments together, and we end up with this. Now we're ready for the next step, which is to exponentiate both sides. So my base is 4. So that and that cancel, and I'm left with 16x plus 72 equals 4. 4 to the first power is just 4. So from there, we'll go ahead and solve. And look what I forgot to do again. I forgot to find my domain. I always forget to do that first step, darn it. I end up with negative 4.25. And now we want to make sure that that answer is actually allowed. So we take the argument they gave us, make it greater than 0. We don't have to do it with this one because there's no x on that one. And we go ahead and solve. And just as a reminder, I should have done this at the beginning, but like I said, I tend to forget about that a lot. So long as my answer is bigger than negative 4.5, we're good. Now you might be a little confused by this, but actually negative 4.25 is bigger than negative 4.5 because when it comes to negatives, things are backwards. But there it is. So let's go ahead and take a look at our next problem, number 10. Here's another problem with 2 logs. I'll start the right way this time. I'll find my domain. So we take this piece, make it greater than 0, minus a 4 on both sides, and we end up with x needs to be bigger than negative 4. And for this one, it's just an x, so that needs to be greater than 0. So if a number is bigger than negative 4 and also bigger than 0, then it's got to be to the right of 0, right? So really the only one that matters is this. So long as my number is bigger than 0, then it'll be a good answer to have. So I'm going to put that at the top so I don't forget about it. Next, we're going to go ahead and solve the logarithm. So we need to get the log by itself, but in order to have that, we need to put these 2 logs together as one. And for this one, when you have subtraction between 2 logs, you can put them together as 1 log so long as you do the argument of the first one divided by the argument of the second. Okay, so on the last problem, we saw that addition becomes multiplication. So on this one, we see that subtraction becomes division or a fraction. Okay, from there, we have the log by itself, so we're ready to go ahead and exponentiate both sides. So we have log base 2 of x plus 4 over x, and 4 over here, and we're doing a base of 2. So these cancel out, and I'm left with x plus 4 over x on the left side, and on the right side we have 2 to the 4th power, which is 16. From there I want to solve for x, and with these fraction ones, the first thing you want to do is multiply both sides by the denominator number. That way these cancel each other out, and we'll be left with a non-fraction now. Then you're going to combine your terms, solving for x. So I get 4/15, and 4/15 is bigger than 0 because it's a positive number. It's a small positive number, but it's still positive and greater than 0, so we're good to go. All right, let's go ahead and take a look at number 12. All right, just do our domain first. This one and this one, we don't need to check the domain because there's no x there, so we don't really care. But this one, we need to check our domain. We have x squared plus 2 needs to be greater than 0. So if I try solving this, we're going to take a square root. Now, when you get a square root, you're always going to get 2 answers. You're going to get a positive answer and a negative answer. And for the one that's negative, you're going to reverse the inequality, and for the one that's positive, you keep it the same way. Now, in this particular problem, it doesn't really matter, though, because there is no such thing as a square root of a negative, so there's no solution to this, and what that means is that x can be anything. So no matter what answer I get when I solve this equation, it's going to be a good answer because there's no restrictions on what x is allowed to be. This is a process where we try to find out what is x limited to. Well, I didn't get an answer, so that means x is not limited to anything. X can be anything, right? So let's go ahead and solve. So once again, I've got 2 logs on this side, with a subtraction sign between them. And when that happens, we saw in the last problem, you put them together as one log with division. Like so. The next step is to exponentiate both sides, or in this case, just to kind of make life easier on ourselves, when you have a log on both sides, you can just drop it off like that. Or you could exponentiate. You'll still get the same answer, though. And when you have a fraction, we talked about how in the last problem, the first thing you're going to do at this point is multiply both sides by the denominator. And then from there, we're ready to solve, so we'll subtract the 2 on both sides. 16, you take a square root, and don't forget, when you get a square root, you get a positive and a negative answer. And the square root of 16 is 4. Now, you need to make sure that these actually are allowed. And there's 2 answers, so you need to make sure both of them are allowed, 4 and negative 4. But remember, for me, on this problem, x was allowed to be anything, so I'm going to keep both answers. But for you, when you do a problem, if you check your domain and you get 2 answers, make sure they both fit. They're both allowed. All right, let's go ahead and take a look at number 14. So on this one, we have 2 logs that are being subtracted. We want to put those together as one log, where the argument of the first is divided by the argument of the second. And for this one, we're going to exponentiate both sides now. Oops. And we're using a base of 9. So I'm left with x squared over 4 equals 9 squared, which is 81. We're going to multiply both sides by the denominator. And then we're going to take the square root. You could use a calculator if you want to. I don't think they're going to have these ones come out to be weird square roots. You could do it by hand by breaking it apart into pairs, right? And then taking out the pairs. Or you could just use a calculator. However you want to go about doing it is fine. But it turns out that the answer is going to be plus and minus 18. And I forgot to check my domain again. So let's go back and do that. So x squared needs to be greater than 0, which means that x can be either, when you square root both sides, x can either be less than 0 or greater than 0. Okay? So it could be either one, and in either case, both of those work, so we're good. Let's go ahead and take a look at number 16. So we're switching gears here now. We're no longer talking about solving log equations. We're now solving exponential equations. So back in chapter 8, we learned how to do these, and it was by getting these bases to match. But in this case, that's impossible. There's no way I can get both of these to be a number raised to a power where that number matches on both sides. So when you have an exponential equation like that, the only way to do it is by logarithms. So what are the steps for solving these ones? The first step is to get the exponential part by itself. That's the part where you have a number raised to a power. And as you can see, I've already got that. So the next step is to log both sides. So I'm going to log both sides. Now when you do this, your log needs to have the base of whatever number's here. And in this case, that's a 10. I'll write 10, but as you guys may know, you don't have to write 10 if it's a base 10, but I'll do it just for clarity's sake right now. And the reason we do that is because these cancel each other out, leaving me with v, and I've got log base 10 of 84. And for this, we're going to have to use our calculators. Now, since it's base 10, I don't need to use the change of base. Okay, I can just type that right into my calculator. the way it looks, and it'll tell me. And I get 1.924. Okay, let's go ahead and move on to number 20. So let's get the exponential part by itself. This is the exponential part. So I need to get rid of the 4 and the 9. I get rid of the 9 by adding. What would that be? I think it's negative 32. And then we're going to divide both sides by negative 4. And by doing that, I end up getting the exponential part by itself. All right, so after we get the exponential part by itself, we're going to log both sides using a base of 19. So on the left side, those cancel, and I'm left with 2 minus 7k. On the right side, we have log 8 base 19 here. So that one, we have to do change of base on that. So change of base requires me to do log base 10 of 8 over log base 10 of 19. And my calculator will come in handy for that part. And for that, I get 0.706. Then we're going to subtract 2. Let's see, what would that be? Let me pull out my calculator here again. We're going to minus 2 from that. I get negative 1.293. And then finally, we're going to divide both sides by a negative 7. And I end up with 0.185. Okay, and there it is. All right, let's go ahead and move on to our next problem, number 22. All right, so for the word problems, we're going to need to create our own equation to solve it. And you have 3 exponential formulas that you would have to choose from. You have the general formula, which looks like this. You have the compound problems, which look like this. And then you have the continuously compounded ones, which look like this. Okay, so the way you could tell which one it is, you look for the key word. If it says compounded, it's this one. If it says it's compounded continuously, it's this one. If it doesn't say either one of those, then we're just going to use the general format for an exponential function there. So the steps for solving these look like this. So pick a formula, one of these 3, plug in the given information, and then use the steps that we just went through on the previous couple problems for solving exponential equations. All right, so without any further ado, we'll go ahead and get started here. It says, Wilbur invests this much money in a savings account with a fixed annual interest rate of 5% compounded 6 times per year. How long will it take for the account balance to reach this much money? I see my key word here, compounded, and it's not compounded continuously, it's just compounded. So I know that I'm going to be using this formula here. So let's go ahead and get that all set up. All right, so the A represents the final amount, which would be this number here. So I'm going to put 5, 5, 2, 3.5 here. The P represents the starting amount, which is 4097. The R is this number here, but we have to remember to change our R into a decimal by dividing it by 100, and we get 0.05 as a result. The N is how many times it's compounded, and that would be 6. And so N is 6. Now my goal here is to find out how long, which is T, so I'm going to leave that as a variable. All right, so there's our setup. All right, so from here we're going to start using our calculator a little bit to help us out. I'm going to begin by simplifying this piece here on the inside. So to do that, I'm going to do 0.05 divided by 6 first. And that's what this piece would be. And then I'm going to add 1 to it. So I get that. So let's go ahead and write that first. Okay. So there, I've plugged everything in. And now we're ready to go ahead and start using our steps for solving exponential equations. This is the exponential part right here. So I want to get this by itself, which means I want to get rid of the 4097. So I'm going to divide both sides by 4097 first. So that goes away. And for the left side, I need my calculator. So 5523.5 divided by 4097. And I get 1.348 there. Oh, that's not a 6. Let me rewrite. That was supposed to be a 0, my bad. All right. Then the next thing that we do is we log both sides. So let's do that. And we're going to be logging both sides with a base of the 1.0083. All right. On the right side of our equation, the log cancels out. Oh, I didn't write that correct. My bad. Let me back up a little bit. There we go. That's what I was supposed to write. Sorry about that. On the right side of my equation, the log 1.0083 cancels out the 1.0083, and I'm just left with 6t. On the left side of my equation, we need to do this on our calculator using the change of base. So it's going to be log of 1.348 over log of 1.0083. And we'll go ahead and punch that into our calculator now. And I'm getting about 36.144. And then from there, we're good to just solve by dividing by 6, which is going to be something pretty close to 6. Let's see. I think it's 6.024. And with these problems, we're rounding, so don't be surprised if the answer, on a multiple choice test just says 6 or something really close to that, because we're rounding all these numbers as we go, so it's a little bit off with perfect accuracy. But there it is. All right, so let's go ahead and take a look at one more type of word problem here, number 24. This one is different than 22 because this one says compounded continuously, which means that for my first step, we're going to use a different formula, which is this guy here. Okay, so the y represents the final amount. The final amount is this guy here. The P represents the starting amount of money. E stays right where it is. R is this number, but divided by 100. Now usually with these, you have to decide if the R is positive or negative. But with these interest rate questions, they're always positive, so we don't have to worry about that. And I'm looking for time, which goes right here. So there's that one. And we're ready to continue. So my goal here is to solve this equation. To solve an exponential equation, we want to get the exponential part by itself. So my first step is going to be to divide both sides by 7,921. These go away like so. And for the right side, I'm going to go ahead and do my calculator work here. 14433 divided by 7,921. And I get 1.822. All right. Next thing I want to do is get rid of this E. And the way we do that is by logging both sides. So we'll do ln, since it's a base of E this time. Oh, forgot to do this side. And on the right side, the ln and E cancel, so I'm left with 0.06t. And on the right side, typically we would have to do change of base, but since this is ln, that's actually right on my calculator, so I could just type it in and have my calculator do that for me. 1.822 natural log is 0.59999, which means it's basically 0.6. So if you rounded it, and then we divide both sides by 0.06. And I think we're going to find out that that's 10 if I'm not mistaken, but I'll check just to be sure. And there it is. So that one comes out to be 10. All right. And that ends it, so hopefully that was helpful. We'll see you guys in class for a quiz. Have a good one.